welcome to
Hey
Ladyada.
everybody. Okay, hopefully you guys are staying nice and cool, hydrated. It is hot in here, but that's okay because we're gonna do electronics and keep the fan on. So let's take a look at what we're working on. Let's go to the computer first, and I'll show. We got a whole bunch of prototypes in. So first is this IR transceiver. I also got the IRDA boards in, but this was a little easier to get tested, so I thought I would do that first. It's just a board, it's my standard 1" by 0.7" size with two IR LEDs on the output here, one IR receiver, two little indicators to let me know when data is received or transmitted, breakouts here, and then a JST-PH cable to make it, basically easy to do infrared projects when you're receiving and transmitting IR signals. Let's go to the overhead. I'll show it real fast. So this is the final prototype assembled, and you can actually see, it's very bright. These are very high power LEDs. So this is transmitting IR, and it's actually also receiving it because obviously this receiver is so close to the transmitter. Let me remove the transmitter for a second so we can be a little bit more controlling. So this is, I've got like an IR remote here, and when I let's see if we can get a better focus. When I send some signal, you see the in LED is lighting up, and then if you go to the computer again, I've got it basically running this code that transmits a random number and then receives it. And so let me see, I think I disconnected by accident. Let me see, is this? Yeah, okay. So yeah, this is just sending data, receiving data on two different pins. This is a good little, I like loop back testing. It's like this thing tests itself. Obviously you can see the IR LED on the overhead. But this is basically good if you have a project where you want to receive infrared signal and transmit it. Like maybe you're communicating back and forth. Maybe you're doing some home automation stuff where you want to take one remote and then relay it to another. It's only for 38 kilohertz signals, 940 nanometers, but that's like 90% of infrared remotes. So this board is good to go. So I'm going to disconnect it. And that'll be kind of nice and popular. It doesn't, one thing is it uses this JST-PH cable. It's not I2C. I use this cable for I2C connections. It's not I2C. We don't really stock Grove cables. Like Grove would be kind of a more logical thing. It's more just like two data pins and two power pins. So that's that. Okay, next up, well, let me grab this is my USB Type-C. Okay, so let's go to another board. So another prototype I got today is the USB. So we've got this in the store, this HUSB 238 breakout. It's like it's a dummy board. So you connect it to a USB-C power delivery device, and then depending on what resistor you short over here, 5, 9, 12, 15, 18, or none of them, which is 20, you'll get 20 volts on the output. And you can also use I2C to connect to it. And this board works very well, and I wanted to make something low cost. But a bunch of people were like, well, I don't want to do any soldering. I want something that's really easy to switch back and forth. So I designed back here a version that's more plug and play. It's basically the same. It's basically the same schematic, but instead of jumpers, there's there's a terminal block on the output. There's an LED that lets you know like data, power's coming through. Stemma QT connection here for like plug and play. Still have USB-C here. The HUSB, pass transistor, and then dip switches. I think a couple weeks ago we did a great search where I showed how to find half-pitch dip switches. And so I was like, oh, this is a perfect project where you want a little dip switch, but you don't want like the big standard size because it would like be the size of the entire board. So you just flip the switch that lines up to the voltage you want, and you're good to go. So let's go to the overhead. So here I've got my USB-C, and this is connected to like, you know, a power supply that I have, which provides like pretty much all voltages. This is the board, so you can see the green LED lit means power is good. And then I have a multimeter, voltmeter here. Let's put it into DC mode, and then I'm just going to clip onto the probes of the multimeter. So, okay. So by default, you get 20 volts because I have, you can sort of see here, the switch is on 20 volts. So if I grab my, use tweezers or a little screwdriver. So if I flip on, the only thing is I think this power supply doesn't do 18. Yeah, so if I flip on the 18 switch, it goes to 15. And then if I go to 15 volts, like I said 15, because this power supply can supply 15 volts. 12 volts. 9 volts. And 5 volts. So yeah, you can see it's very easy. It actually happens, which I didn't realize it happens dynamically, like as you flip each switch. The only thing is that you unswitch it, it goes back up to 20. So definitely like I have a big warning on the silk screen that says like unplug before you switch the voltage, because otherwise, you know, it'll pop to 20 real fast. It can go up to 20 volts. And you can always, of course, you know, do more advanced dynamic switching via the I2C port. I really like this chip. It's a great, I love that I love chips that are both like resistor settable and I2C settable. I think that's a kind of a nice, you know, either you want it to be dynamic or you want something that's microcontroller-less. And of course, terminal blocks in the output. You can disable this LED if you want. But what's nice is actually the LED does kind of tell you that, you know, the brightness does change. So it's like, okay, that's 5 volts. And then, you know, 12 volts is a little bit more. And then 12 volts, 20 volts is the most. Okay, so this board is good to go. So that's booked. So we'll get that into the shop soon. I think this will be good for people who are like, oh, I just want, you know, USB-C to replace a DC power supply thing. And then, of course, if you want a DC jack or plug, for some reason we stock those in the store, you would just plug it in and can have either polarity you want. Okay, so that's that. And then the last thing is, the last prototype is, let's go back to the computer. Level shifters, you know, I guess like 700 designs almost. So it's like a lot of folders. The RS-232 PAL. So this was a board because I wanted to maybe do some interfacing with some older computer type things that use RS-232. So this is just a simple 222 transceiver. And I think either last Great Search or the one before that, we found this part. So it can, you power it with 3 to 5 volts over here. It gives you plus minus 6 volts, you know, 6 to 10 volts. On the output, it can also get in plus or minus 12 volts. Maximum, because that, you know, the other side might have a higher voltage. So it's, you know, voltage protected. And then gives you level shifted down and up. So you can have 2 pairs. So RX and TX, RTS and CTS. So then to test it, what's actually kind of cool is I happened to get a sample like this week for, okay, if you go to the overhead, I got, it's a USB cable that has RS-232 TTL and RS-485 output with terminal blocks. It's like perfect for testing. I also got a version that has USB, like a reversible USB, if you don't want the cable. But I actually love this. This is great because it's like exactly what I need to test this board. Because what I did, it's kind of like a little hairy here. Maybe I'll put it on this side. So I connected the shared ground, which is this yellow cable here, to the shared ground over here. And then I'm powering the board from, I just have a microcontroller board just to provide 3 or 5 volts. And then I have the TX pin going into the transceiver. And then on the other side, I connected the RX to the TX on both ends. So the TX comes out here through the transceiver, gets a little shifted down, jumper to the next pin over, which is the other input, back out, and then into the RX. And then ditto with the CTS and RTS. And what that means is basically like, you know, it's like the infrared, it's a loop back. Of course, I use my oscilloscope to check the voltages and the signals coming through, but it's like a very quick way to verify the signals. So if I go to, gotta open up. I love XCTU, by the way. Okay, so go to computer. I use XCTU. My favorite terminal. I mean, it's not good for general purpose terminal, but for this kind of stuff, it's great because it has this line status is at the top. There's probably other terminal programs that do this, but this is my favorite. So as I type, you see there's blue, that means transmitted, and then red, which means received. So you can see the data, like that's another thing about this terminal program. It shows you both transmitted and received in different colors. And if I disconnect the loop back wire, you see only blue, right? Because it's only transmitting. And then, oops, definitely. There you go, wrong wire. Connect it back. Okay, so you see, you know, as I type, it echoes. And then the other transceiver pair, I've connected to CTS and RTS. So as I click the RTS, you'll see the green CTS button matches, goes back up and down. So now I know, you know, the loop back works. So this board is also good to go. I also have the full 9, like 5 and 3, sorry, 8, 5 and 3 transceiver version. If you go to the overhead, but I'm actually still. I think I got the TX and RX flipped, which, you know, classic. But this one is good to go. The little one's good to go. This one I think I need to do a little bit more work on. I might cut some traces and just see if I can get it working. But then I'll have the full transceiver version as well. Okay, how are we doing on time?
Good 13 minutes.
Okay, great, perfect. So next up, let me just clear this space. So the next project I'm working on, and this is Liz is actually doing most of this project. I'm just helping out a little bit. This is a IKEA VINDRIKTIng. So this is a PM 2.5 sensor. I'm using it now as like a little holder for my screwdrivers. It's got IR LED, sorry, red, green, and yellow IR normal 0603 LEDs on the top. There is an IR LED here too. I have to figure out what this is. Either it's controlling something or gets data from it. I don't know. I have to probe. And then it just displays the. Actually, I didn't actually turn this on. Maybe I'll just power it up really fast to see what happens. Yeah, so the LED lights up to let you know what the air quality is. So like green, kind of a nice little pulsing thing. So now the air quality is pretty good. But you can see it has 4 LED sets: green, yellow, and then red. So 4 LEDs. No IoT other than the infrared. You know, maybe it's a transmitter. Little 8-pin microcontroller, kind of generic, probably 8051. UART signal to the PM 2.5. Here is generic, and then a fan control to turn on and off the fan. And there's like every debug pin. So like, you know, we have a guide on how to solder onto these wires, these pads here, and then you can connect an external microcontroller. But we thought it'd be cool to make a board that fits in, you know, into this and has like an ESP32 so that you can then take it to like Home Assistant or to Adafruit IO or to whatever, you know, IoT service you want to get the PM 2.5 data. And I was thinking of using the ESP32S2 because it can do SSL, which the 8266 can't quite do, but it's very low cost. We covered it in the Great Search before. Low cost, but can do, you know, has USB, can do Arduino, CircuitPython, MicroPython, anything you want. And that would let you read the data from the sensor and still have LEDs on the back, but it can now transmit data over Wi-Fi, maybe Bluetooth, maybe Zigbee. Okay, so that's it's still totally in progress, but coming soon. So let's go to the great search.
Where in the world is that part I need? The Great Search with DigiKey.
Great search brought to you by DigiKey and Adafruit. Every single week, Ladyada uses her powers of engineering to help you find things on digikey.com. What are you looking for this week?
Okay, this week I'm working on a project. Just introduced it, taking this IKEA VINDRIKTIng PM 2.5 sensor, which is a lovely little desktop air quality sensor, and IoTifying it. So let's go over to the overhead. I'll just show it off real fast since this video is going to be clipped. So this board, this is the sensor, taking it apart. Powers over USB, has a little 8-pin microcontroller, connects to a PM 2.5 sensor here, has a little fan to keep the air, because you have to have air circulation to pull air in, measure the particulate matter. And then it lights up the LEDs in the front to tell you, from red to green. Green is good, and then yellow, medium, red, dusty, open up the window or close the window if you're in a California during wildfire season. And we wanted to make a version of this board that replaces this microcontroller with an IoT capable microcontroller. So probably an ESP32S2, but folks support, it'll be open source. You can of course revise it and design it. So let's go quickly to the computer and I'll show just sort of a rough idea of where we're at. Liz is doing the design. I'm just showing this off. And she'll also do a video probably about this project. But so we have like a Wi-Fi module. It's a little bit big, but again, I went with the least expensive. So it's a little, the larger one is less expensive than the compact version. We have 4 NeoPixels on the back. So you'll have like purple if you want. I2C if you want to add more sensors, and then the PM 2.5 and fan connector, power and reset buttons. And we just give a little bit of like a bloop out here, which is fine. There's actually a lot of, if you look at the overhead real fast, there's a ton of space. So you can see like it's totally cool to just like have a little bloop area over here, because this is the PM 2.5 sensor is what dictates the width, and then this board is quite slim. But the thing is, if I want it to fit, I have to have it fit through this slot, and then there's a little like a notch here, and that's all good. Use calipers to measure it. But the challenge is I want also to have it use the same USB-C connector here, and this is a vertical connector. And if you'll notice, get nice and close, it is very blurry. It is very compact. It's right up to the edge of this PCB, which then sits up against this plastic piece. So it's like, I don't have a lot of clearance. I need something that has ideally no more than the width of the USB-C socket in clearance. You can see this version has 2 prongs on each side, and you can see the contacts over here. Okay, so this is the yeah, you can see USB 1, and it doesn't have a part number on it, but I want something similar. Surface mount, ideally, it's pick and placeable, but I like the mechanical through hole, obviously, so it doesn't get, although it has the plastic, so I'm not too picky. It can be a surface mount tab if I absolutely have to, but I think most will be through hole. And then of course I want power and data, because the microcontroller that I'm going to be using will be programmable over USB. So let's go to the computer. And I think we did a great search about USB-C connectors. Like here's a board with USB-C, but this is horizontal, and I want vertical style. So let's go to DigiKey. Let's do USB Type-C to get started. So I want USB, DVI, and HDMI connectors. Correct. And let's also always start out with looking for just active. So let's just use that to filter out. And then I always take to pick the dash in case there's something I want to miss. USB-C, I don't know what stacked is, so I'm just going to select it. So I want USB-C to fit into that same slot, and then I want it to be a receptacle, because it has, the cable plugs into it. So let's start with there. Okay, we've already narrowed it down. Let's take a look. Yep, these are USB-C. Ooh, this one's a vertical one. Just a good start. But I still have the horizontal. I want to definitely only get the vertical ones. There's a lot of horizontal style ones. So let's look for how we select for vertical. Okay, here you go. So horizontal, bulkhead, no. Flange, I don't know, vertical flange, I guess is okay. I don't know what reversible vertical is. The old USB-C is reversible. And vertical flag, also don't know what that is, but we'll pick it up. Okay, so let's see what we got. Okay, so these are looking good. So these are all vertical. And you'll see some of them have, like I said, little like prongs that come out, which I don't want. I need it to be very slim. It's also like this version. This is flag type, which I don't want. I don't know what the reversible is. So let's get rid of flag because I want flag. It's not that many. And then another thing is, I was like, oh, I only want one port. I don't care too much about the voltage or current rating because it's going to be definitely run off of 5 volts. It's going to be very low current. Let's look at normally stocking. So get rid of the unavailable ones. Okay, cool. So this actually, like the first one looks perfect. Let's sort by price because I do want to have this be somewhat price sensitive. And there's actually one that's like pretty much exactly what we've got on the board. Remember, it's got the 2 side prongs. So I was like, yay, let's take a look. And then I realized when I looked at the data sheet, when I looked at the drawing, that it didn't have all the connectors exposed. It only has power, CC1 and CC2. So it's only 6 pins, and that means it's a power only USB-C, which is totally valid. And when I looked actually at the board, let's go to the overhead real fast. If you look at the board, you'll notice this is a power only connector. There's only 6 connectors here. So to save cost, they went with the power only USB-C. So this microcontroller that they've got here is like ROM, flash program, whatever. It's pre-programmed that nobody's gonna mess with it. So they didn't make it, it's not USB capable. So let's go back. We want to filter those out because we don't want, there's quite a few of these USB-C. And what I noticed is that they say number of contacts 6 plus 18 dummy. And what that means is there's 6 active and 18 are, they're on the socket connector, but they're not brought out. So we don't want those. So let's go back up. So we see 24, 16 plus 8 dummy. That means some are not connected, but there's more than 6. We definitely don't want the ones that only have 6. So we're going to filter those out. So we only have the ones that have data connected through. Okay, great. So actually we're looking pretty good. So now we're starting to get connectors. The only thing is, as you see this one, it has those legs that come out. I kind of don't want those. I really want to minimize that. I also only, the more I looked, I was like, oh, there's a lot that have like the pads come out, the pins come out. But then I found some good options here. So these here looked really promising. Even though they don't have the 2, I couldn't find any that had like the 2-pronged connector. I did like that these, you see how they don't like come out. They're nice and flat. And there's a lot in stock. And the price is not too bad, 70 cents per. So looking at the data sheet, it's not as slim as, I don't know, although it's not too bad, like the pads for the mounting holes are not, they don't really come out past the connections for the data pins. And if you look at the pins available here, you have ground, power, CC1, SBU, data plus, data minus, 2 and 1, so both sides. So we'll definitely have data and power available. So this is it. I think this is going to be the right connector, and you can see here, I actually picked a slightly different connector and then realized I think I have to squish it in. So I'm probably going to change from this kind of like large pitched to, this one's a little finer pitched. but we'll be able to go right up against that plastic piece and fit in the enclosure. So I think it's going to be a much better bet to fit for my update board for the IKEA VINDRIKTING. So check this out. This is my pick for the Great Search.
It's a great search.
Where in the world is that part I need? The Great Search with DigiKey.
That's the show. See everybody throughout the week.
All right, stay hydrated, stay cool, everybody.
Bye.